Hello everyone. So welcome to our new lecture. Now in this lecture we are going to see how to balance a given chemical equation. In the previous lecture we have studied that how to write a chemical equation. Now before going to balance the equation, let us see what is meant by balanced equation and what is meant by unbalanced equation. So we know that in a chemical equation we have reactants and product, okay, and the chemical composition of the product is not similar to that of the reactant. So what is a balance equation? It is an equation wherein the number of atoms of a particular element in the reactant side is equal to the number of atoms of the same element in the product side. Okay, so if any equation where you will find that this statement is true, that we can say this equation or the given equation is a balanced equation. Let us try to understand this by example. So the reaction of silver nitrate, that is AgNO3, with sodium chloride NaCl will give us silver chloride, that is AgCl, and sodium nitrate, that is NaNO3. Now in this reaction you can see in the reactant side number of silver atom is 1, and also in the product side you will see the number of silver atom is again 1. In reactant side number of nitrogen atom is also 1, and in the product side also the number of nitrogen atom is 1. Number of oxygen atom is 3, and in the product also the number of oxygen atom is 3. Sodium 1, and in product also sodium is 1. Chlorine 1 atom in the reactant side, and also in the product side chlorine 1 atom. So by this you can see the number of atoms of element in the reactant side is equal to the number of atoms of all those same elements in the product side. In that case we can say the given chemical equation is a balanced equation, where if the number of atoms are unequal in both the sides, then we can say that the given chemical equation is an unbalanced equation. Now let us see how to balance if the equations are unbalanced in nature. Now let us try to understand how to balance a chemical equation with an example. Here we will take an example of reaction of sodium hydroxide with sulfuric acid, and it will give us sodium sulfate and water. Okay, a very simple reaction that is. Now first step to balance a chemical equation is that write the given chemical equation as it is. Okay, so the equation will be now sodium hydroxide, that is NaOH, that is sodium hydroxide, plus is reacted with sulfuric acid, that is H2SO4, and it will give us sodium sulfate, that is Na2SO4, plus water, that is H2O. It is H2O. Okay. Now in this reaction you can see number of sodium atom in the reactant side how many sodium atom is there? 1 sodium atom is there, so 1 Na in the reactant side. Okay, but in the product side you can see there are 2 atoms of sodium. Okay, then oxygen atoms, total 5 oxygen atoms in the reactant side, whereas in the product also you can see there are 5 oxygen atoms. Now hydrogen atom, there are 3 in the reactant, and in the product side there is only 2 hydrogen atom. Now at the end, sulfur atom, which is only 1 in the reactant side, but in the product you can see again, okay, 1 is there, so 1 sulfur atom. Now you can see that the hydrogen atoms in reactant and product side are not equal, and the sodium atoms are also not equal. In that case, this equation is an unbalanced chemical equation. Now as it is unbalanced, we have to make it balanced equation. So for that purpose, what we have to do, we have to write the equation in such a way that number of atoms in the reactant and the product side for a particular element will be same. So in that case, now sodium atoms in the product side is 2, definitely we want 2 sodium atoms in the reactant side also. Now we cannot change these numbers, okay, which are suffix to the molecules, okay, these numbers. You cannot change this 2, you cannot change this 4, you cannot change this 2, 4 and 2. We can only take numbers as a coefficient. That means we can increase the number of molecules of a compound, but we cannot change a single atom in a molecule. Okay, so this is the molecular compound. So in this particular compound, I cannot change this O and keep that Na and H as it is. Okay, if I am changing this O, I have to change the Na and H also, because I have to take the coefficient. That means I have to increase the number of molecules of the compound. Okay, so there are 2 sodium atoms in the reactant. I want 2 sodium atoms in the product. I want 2 in the reactant also. So what I will do, I will take 2 molecules of sodium hydroxide. So 2 NaOH plus H2SO4 will give me Na2SO4 plus H2O. Now you can see that number of sodium atom in the reactant side is 2 and the number of sodium atom in the product side is also 2. Okay, but the number of hydrogen atom, now in the reactant side you can see there are 4 hydrogen atoms, whereas in the product side you will see there is only 2 hydrogen atoms. So now we have to balance the number of hydrogen atoms. Along with that, you can see now the number of oxygen molecules or oxygen atoms is 2 plus 4, 6, whereas the number of oxygen atom in the in the product side is 5, 4 and 1, 5. Okay, so along with hydrogen we have to change the number of oxygen atoms also. That means we have to balance the oxygen atom as well now. So how we can do that? Now you can see sodium is balanced, so I am not going to change this anymore. Okay, again if I change something over here, it is going to change the number of sulfur atoms also. Okay, if I take the coefficient over here, any coefficient, that is going to increase the number of sulfur atoms, and I don't want to do that. That means now I will not going to change anything in the reactant side, but I will change it in the product side. Okay, now again I cannot change Na2SO4 as my sodium atom is balanced. Okay, I have balanced my sodium atom. Definitely I cannot change this, I cannot alter this particular molecule. So I will alter the water molecules. That means I will increase the number of molecules of H2O. So as you can see, number of hydrogen atoms in the reactant side is how much? It is 2 plus 2, 4. Okay, so I want hydrogen atoms, 4 hydrogen atoms in the product side also. From the beginning itself you will see that 2 hydrogen atoms are there. That means I have to increase 2 more. Okay, so what I can do, I will take 2 NaOH. Okay, we are not going to alter this sodium hydroxide. Again we will keep the hydrogen sulfate, that is H2SO4, sulfuric acid as it is. Also, we are going to keep sodium sulfate as it is, and we will be altering the molecules of water. So I will take 2 molecules of water, 2H2O. So 2H2O, that gives us 4 hydrogen. Okay, 2 into H2, that will be 4 hydrogens. Okay, and number of oxygen is now 4 plus 2. Okay, here it is 1. So 2 into 1 is 2. So 2 plus 4, that is 6. And in the reactant side also you can see 2 plus 4 is 6. Okay. So now you can see that 2 atoms of sodium, 6 atoms of oxygen, 6 atoms of oxygen. Okay. Then 4 atoms of hydrogen, 4 atoms of hydrogen. Okay, 1 atom of sulfur and 1 atom of sulfur. In that case, number of atoms of an element are same on both the side. So we have got a balanced equation now. So at the end we can write a complete balanced equation, that is 2NaOH, 2 molecules of sodium hydroxide plus 1 molecule of sulfuric acid gives us 1 molecule of sodium sulfate plus 2 molecules of water. Okay, also we can write the states of this chemical. Okay, definitely aqueous state, aqueous, this will be in sodium sulfate, okay, solid state, and H2O, that is in liquid state. Okay, and also we can write down their molecular names: sodium hydroxide, sulfuric acid, sodium sulfate, and water. So in this way we can balance a given chemical equation if it is unbalanced equation. Okay, in the description you will find a link where you will find 2 unbalanced equation converted into a balanced equation. You have to write down those equations and also this equation complete with their steps in your notebook. In the next lecture, we will see the types of chemical reactions. Okay, until then, goodbye.